So here we have discrete time signal. So you can see that this is a discrete time signal. Okay. So can you see that this is periodic? No, can you see it? So you can see that this is repeating. No, this one, this part again repeating here. Okay, and this part again repeating here, and also this part again repeating here, this one again repeating here. Okay, so within a finite time duration this signal is repeating. Okay. So you can see it. So we call this is a periodic signal. No, so we know that this is a discrete time signal, so this is discrete time periodic signal. Okay. So because this is a discrete time periodic signal, we should be able to represent this in Fourier series representation, no? As a collection of exponential harmonic signal. Okay. So we will go to that this one, no? So this is our identities. Okay. So I have write it somewhere because I always forgot these things. Okay. Okay. So I will write it here. Okay. So we know that any periodic signal, actually any is wrong. Okay. Any periodic signal we can't represent using the Fourier transform. Okay. Some condition should be satisfied. Okay. But we can say most of. Okay. We can say most of. Normally we refer as any. Hurry. But it is not totally wrong. Okay. So you can refer your reference book for more information if you need. Okay. So you can see that this is a periodic signal. Okay. So let's tell any. Okay. Without considering that complex things, we will say any periodic signal can be represented using the Fourier series. Okay. It is not totally true. Okay. So so this xn also can be represented as a collection of harmonics, as a collection of complex exponential harmonics. So here k is from 0 to n naught minus 1. Okay. Ck e to the power jk omega naught n. Okay. Likewise, we can represent this signal. Okay. So these are the complex exponential terms. Okay. So we can say these are harmonics. Okay. So first thing we have to do is we have to find the period n naught of this signal. Okay. So can anyone tell me what is the period of this signal? Okay. So if this is a continuous time signal, period is this. No, this from this one and this one. This is the period, no? Isn't it? If this is a discrete continuous time, the period is this time duration. Okay. So how can we find the period here? How can we find the period? Okay, if this time is, let's say t2, this time is t1. How to find the continuous time period? We have to subtract this time from here, no? T2 minus T1. So in this way, we can find the continuous time period. Okay. So how to find the discrete time period? So here it is this sample and this sample. Okay. So here you have 1, 2, 3, 4, 5 sample. Okay. 1, 2, 3, 4, 5 sample. Okay. 5. Okay. So this is, if this is 1, if this is 1, 2, 3, 4, 5. Okay. So I have to subtract 5 from 1. No? So this is 5 and this is 1. Then we have 4. Okay. So what is the period? It is 4. Okay. So so why I am telling you is that Okay, sometimes you may confuse that, you may think that period is 5 because 5 sample is there. 1, 2, 3, 4, 5. Okay, so within this 5 sample is there, but not 5 samples. Okay, period is, this sample should be, and the difference between this sample and this sample. Okay, so that is the period. No, difference between this time point and this time point is the period for continuous wave. Okay, and for here, difference between this sample and this sample is the period. Okay, so the period is 4 here, not 5. Okay, hope you get it. Okay, hope you can get it. Okay, so this is 4 minus 0. It is a, if this is 0 sample, if we consider this as 0, 1, 2, 3, 4, then it is 4 minus 0. Okay, that is also we have 4. Okay, and if you consider this one, okay, this is the, if this is the 8 sample, okay, so 9, 11, 12, 13. So no, after this repeating, no. So after here the repeating. So this is 9 sample. This is 1, 2, 3, 4. That is 30. Okay. So if you find the this difference, you have to subtract. This is 13 sample and this is 9 sample. So you have to subtract 13 9 from 30, so that you have again 4. Okay, correct. Okay. So the sample, the period is that 4. I hope you understand it. Did you get it? Okay, anyway, I will tell again once more. Okay, so say this, we have this kind of signal. Okay, this kind of signal. So this is 1, 2, 3, and again this is repeating like this. This is again 1, 2, 3, and here it is again repeating like this. This is so this is 1, 2, 3. This is 4, 5, 6, 7, 8, 9. Likewise. Okay. So if you ask to find the period here, you can say that after this point, it is repeating. No? After this point, it is repeating. Okay. So if you ask to find the period, so this point is 3 and this point is 1. Okay. So period is 3 minus 1, 2. Okay. Okay, so if you ask the period here, so here it is 7, 8, 9, and here it is 9 point, and here it is 7. So this period is 9 by 7. It is also 2 because this period are equal. Okay, so that is how we find the number of sample here. Okay, so n naught is equal to 0 here. Okay, okay. Now we know that. Okay, so we will I should tell you that sometimes this k is not 0 to n naught minus 1. Okay, we can't guarantee that k is 0. Okay, because these are number of samples. Okay, so some signal we may have the minus sample also. Okay, we have discussed it. No, we have some minus sample also, -2, -3, -1, 0, 1, 2, 3, 4. Likewise. Okay, so say that this signal sample is 4. Okay, so here we have to find 4 means 1, 2, 3. This way, no? This is our sample. So, this is our period. Okay, correct. So this is 0, 1, 2, 3, 4, 5, 6. Okay, and these are minus sample, -1, -2, -3, -4, so on. Okay, So say that we have say that there is a signal. I didn't draw the signal here. I didn't draw that impulse here. Okay. But say that the period is 4. Okay, period is 4. That means number of sample is 4. Okay, so you can consider this as a period, no? 0 to 4. Okay, 0 to 4. This one. Okay, this as period. 4 minus 0, you have 0. You have 4. This is period. And also you can consider this one. Okay, 1 to 5. So that means 5 minus 1. Also you have 4. Okay. And here also you can have this one. Okay. So here you have 1, 2, 3, 4, 5. Okay. And here also you have 1, 2. I will write another color. Okay. So I am starting from minus sample. Okay. So I have 1, 2, 3, 4, 5. Okay. Okay, so this is my sample. So if I so this is my period. Okay, so this is the starting point and this is the ending point. Okay, so if I subtract the ending point with the starting point, okay, so I will have again 4. Okay, so what I want to tell you is that we can consider this. Okay, so this as a period also. So we can start k is from -2 to 2 if the period is 4, and k is from 0 to 4 if the period is 4, and also k is from 1 to 5 if the period is 4. Okay. So say all are correct. Okay. So here this k0 is not strictly to 0. Okay. So it can be start from -1. It can be started from -2, -3 anyway. Okay. Okay. I hope you got it. Okay. I hope you get it. So we will. So when we are doing some example, you can get this idea very well. Okay. So we will continue. Okay. So so anyway, we have seen that in our signal. Okay. In this signal. Okay. In this signal, the period is 4. Okay. In naught is 4. Okay. In naught is 4. Okay. So we have to find the coefficients from 0 to n minus 1. Okay, that means 0 to 3. We have to find. Okay, so 0 to 3, there are 4 points. Okay, 0, 1, 2, 3. Okay, so you can see from 0 to 3, there are 1, 2, 3, 0, 1, 2, 3. So there are 4 points. Okay, so your period is 4. Okay, because there are 4 points from 0 to 3. Okay, so that is why it is from n0 to -1, because we have to evaluate at 4 point. Okay, so this is n0 is 4, so we have to evaluate at 4 point. If this is start from 0, you have to evaluate it up to 3. Okay, that means you have 4 terms. Okay, 4 sample. Okay, if you evaluate it -1, it is 0, 1, 2. You have to evaluate it up to 2. Okay, again you have 4 sample. Okay, and if you evaluate it from -2, 0, 1, 0, 1, 0, 1. Okay, so you have to evaluate it up to 1. So again you have 4 sample. If you evaluate it from 2, okay, 2, 3, 4, 5, you have to evaluate it up to 5. So you have 4 sample. Okay, so this k and this value can be changed. Okay, but anyway we have to evaluate it with 0 to n0 -1. That means we have n0 value here. Okay, so that is the condition. Okay, here. Okay, so this k sometimes this used as, sometimes this write as. Okay, Sometimes this write as k is k n naught, likewise. Okay, this way also this is written. Okay, but for simplicity, I have, for more information, I have write that it's 0 to n naught minus 1. If you couldn't understand, just keep going, no issue. Okay, when we are doing some example, you will get this. Okay, and also try to get this by yourself. uh, you can refer some note, and you can refer this lecture again, because this will be uploaded. Okay, so try to uh, understand this. Okay, so here we have to 0 to n naught minus 1, that means 0 to 3. So we have to find four coefficients, that is c0, c1, c2, c3. Okay, okay, so we have to find three coefficients. So if we find these three coefficients, we can write our signal as, okay, so here c naught k is equal to 0, c naught e to the power j, here k is 0, so all other things will be 0. Okay, so this one also will be 1. Okay, plus, okay, so this will be 1. Okay, and c1 means k is equal to 1, so k is equal to 1, e to the power j, k is equal to 1 omega naught n, plus c2 e j2 omega naught n, plus a3 e j3 omega naught n. So likewise, you can write this xn, okay, this xn signal as a collection of exponential terms, no? So you can see that the collection of exponential terms are there. Okay, these are the weighted exponential terms. Okay, so you have to find this series. Okay, so to find this series, what you have to estimate? You have to estimate these coefficients, no? We still don't know these coefficients, c naught, c1, c2, c3, this is c3. Okay, so we have to simply estimate this coefficient. So if we evaluate the coefficients, we can substitute these coefficients here, and that is our Fourier series representation, no? Okay, so we will try to evaluate the coefficients. Okay, so to evaluate the coefficients also, we have the identity. Okay, so ck is equal to sigma, okay, here 1 by n naught sigma xn e to the power minus j omega naught kn. Okay, so this is the equation or identity for evaluation these coefficients. Okay, so we will first evaluate the c naught. Okay, so you know that when we are evaluating c naught, that means k is equal to 0, that this k is equal to 0, this a to the e to the power 0 is 1, so we have 1 by n naught sigma xn. Okay, so this is 0 to 3. No, sorry, this is not 0 to 3. Yeah, 0 to 3. Yeah, 0 to 3. Okay, because within one period. Okay, 0 to 3. This one up to here. Okay, so we will see why we not evaluate the 4. You can see that directly we have to evaluate it up to here, no, up to 4. Okay, so let's put it up to 4. Okay, so here 0 to 4. Okay, we have to evaluate. Okay, so here we have e to the power minus j k, sorry, k is now 0. Okay, k is 0, so we don't have this one. Okay, xn. Okay, so this x in this 0 to 4 means n variables. Okay, so here it is k variable. Okay, here it is k. Okay, these values are k. Okay, these values are k. The k is the variable here. Okay, for this one. Okay, for our signal representation. Okay, but for the coefficients estimation, when we are going to estimate the coefficients, okay, this is n. Okay, not k. This is n 0 to n naught minus 1. Okay, n naught 0 to n naught minus 1. Okay, so you can see that this is n. Okay, this is n. That means n represent this sample. Okay, this sample. Okay, n represent this sample. Okay, and represent that sample. Okay, and here it is k. Okay, this is k. K from 0 to n naught minus 1. Okay, so this is k. Okay, the number of harmonics. It is not the impulse. It is not related with our with our graph. Okay, with our signal. So this is the harmonic. Okay, this is the number of harmonic. K is the number of harmonic. Okay, so this n is the number of sample. Okay, this n is the number of sample. Here it is number of sample. Okay, so I hope you got it. Okay, I will tell it again. Okay, this yeah, I have got it wrongly. Okay, and so here I have got it wrongly. Okay, so here this k, it is a number of harmonics. Okay, this is a number of harmonics. Okay, so here it is k from 0 to n minus 1. That means this k should be evaluated through one period. Okay, but here when we are evaluating the ck, here it is not k, it is n. Okay, so this is my wrong. Okay, I have done a mistake here. So this is n. Okay, so n is the number of sample here, the number of sample in our signal. Okay, in our signal. Correct. This is harmonics, and this is number of sample. Okay. So I'm sorry, I have done a mistake, and here also n. Okay. This is number of sample, not number of harmonics. I hope you get it. I have done a mistake there. I'm sorry. Okay. So you may have confused it. So again, I will tell it. Okay. So this is our Fourier series representation for discrete time signal. Instead of integration, we have a summation for discrete time signal. We know that. Okay. So you can see that here. This is our the harmonics, collection of harmonics. Okay, so here k from 0 to n naught minus 1. Okay, n naught is the period, so k is equal to 0 to n naught minus 1. Here you have number of harmonics. Okay, but when you are finding the coefficients ck, here the summation should be done through number of samples. Okay, n from 0 to n minus 1. Okay, I hope you get it. Okay, so here xn is number of samples. So here we have, okay, here we have 1 by n naught, okay, x0, that is n is equal to 0 plus x1, n is equal to 1 plus x2, n is equal to 2 plus, so here it is not 4, n naught 3, no? So you can remember that it is 3 because n naught minus 1, n naught is 4, 4 minus 1, so it is up to 3. Okay, so it's 3. Okay, 5 twice. So we will see that n naught is 4, so we have 1 by 4. Okay, so you can see that this is x0. Okay, then this is x1, x0 is 0, x1 is 1, x2 is 2, x3 is 3. Okay, we didn't consider this point. Okay, so we have 0 plus 1 plus 2 plus 3. Okay, x0 is 0, x1 is 1, x2 is 2, x3 is 3. Okay, so we have 1 to 6, we have 6 by 4, 2 by 3. Okay, so this is our first coefficient, C0. Okay, hope you get it, and we will evaluate the other one, C1. Okay, C1. Okay, so you have 1 by n naught. Okay, sigma. Okay, summation 0 to 3 n. Okay, n equals 0 to 3 xn e to the power minus jk. Jk is, now k is 1, no? So here k is 0, k is 0, and here k is 1. Okay, so here k is 1, jk omega naught n. Okay, correct. So we have this one. Okay, so now we have to do this integration to the sample. Okay, so we can write it here again, x naught. Okay, here we have x0. Okay, and e to the power n is 0 now, so e to the power 0, that means 1. Okay, plus x1, then e to the power, this n is 1, no, e to the power minus j 1 omega naught. Okay, plus, okay, then n is equal to 2. Okay, n is equal to x2 e to the power minus j. Now k is also 1. Okay, k is 1, omega naught n is 2. Okay, and this is x2, and x3 e to the power minus jk is 1. Okay, omega naught, and n is 3 here. Okay, you get it. So we have to evaluate this. Okay, so one thing is that, okay, so when we write this in terms of exponential term, okay, exponential term, okay, so here the fundamental period, okay, fundamental period n naught will be 2 pi by omega naught. Okay, this is the fundamental period. So you can see that omega naught is equal to 2 pi by n naught. Okay, 2 pi by n naught. Okay, so okay, omega naught is equal to 2 pi by n naught. Okay, yeah, n naught equal to 2 pi n naught. So omega naught is equal to 2 pi by n naught. In our case, n naught is 3. Okay, n naught is, sorry, n naught is 4. So we have omega naught as 5 by 2. So omega naught we can calculate. Okay, it is 5 by 2. Okay, so I can apply it here. Okay, so I can do some more simplification. Okay, so I'm going to add it here. So here omega naught is 5 by 2. Okay, so I have 1 by n naught. Okay, x naught is 1, sorry, 0. x1, you can remember that x1 is 1, and we have e to the power minus j 1, omega naught is 5 by 2. Okay, plus x2 is 2, and e to the power j minus jk is 1, omega naught is 5 by 2, and it is n is 2. Okay, so 2 to cancel, here we have 5. Okay, and we have this is x1, x2, x3 is 3, e to the power minus j, k is 1. Okay, 5 by 2, 3. Okay, so we have to evaluate this one. Okay, so we know that n naught is 4, so we have 1 by 4. So here we have 0. Okay, and what is e to the power j 5 by 2? Okay, so it is minus j. Okay, so please check it. You can use Euler formula, and you can write the cosine and sine wave, sine wave and cosine wave, then you can find at minus 5 by 2, what is the value? At minus 5 by 2, what this cos theta and sine theta, what is the value of this cos and sine theta? Then you can verify this. It will be minus j. Okay, I have write it somewhere. That is why I directly tell it. Okay. Anyway, we have to evaluate it. Now I am not going to evaluate it because at 3 o'clock you have another lecture. No? Okay, so I am going to directly put the value here. So you can do it. Okay, you can do this. No problem. Okay. So we have e to the power. So sorry, e to the power minus j 5 by 2 means you will have minus j. Okay. Yeah, you will have minus j here. Okay, plus here 2 e to the power minus j5. Okay, minus j5, you will have minus 1 here. Okay, minus 1 here. Okay, and 3, you have minus 3 5 by 2, you will have plus j here. Yeah, sorry, I have write it here. Okay, that is why I can directly tell it. Okay, otherwise I couldn't tell it. You have to find it. Okay, here I am right. I have write this. Okay, this value. Okay, so here I have 4, here 0, here it is minus j, here it is minus 2, here plus 3j. Okay, so minus j plus 3j, we have plus 2j. Okay, so I have 4 by 2 j minus 2. So this is my second coefficient, C1. Okay, in same manner we can calculate the C3. Okay, I will quickly write the C3. Okay, C3. So anyway, I am doing because I have to upload this. Okay, because so I will continue. Okay, so you can just leave after 3 o'clock. You can just leave, but I will continue this and upload. Okay, so no need to inform. You can just leave at 3 o'clock, but I will continue. Okay, so don't wait until I wind up. You can leave after 3 o'clock. You can leave. Okay, no issue. So here C3. Okay, I'm going to evaluate the C3. So C3. Okay, that means K is equal to 3. Okay, so C3. So here we have 1 by n naught sigma 0 to 3 xn. So this is n. Okay, n from 0 to 3 xn e to the power. So in this case should be 2. No, it should be 2. Okay, K is 2. Okay, omega naught, I will directly write omega naught here. It is 5 by 2. Okay, omega naught 5 by 2, and n is, yeah, n. Okay, likewise I can write this. Okay, so I'm going to do the summation. So 1 by n naught is there. Okay, so here x0 e to the power 0 plus, okay, because this n is 0. Okay, and I have, sorry, x0 here, x1 e to the power minus j 2 5 by 2 2 here, n is equal to 2 here, sorry, n is equal to 1 here, plus x1 x2 e to the power minus j2, k is equal to 2 5 2 into 2 plus x3 3 e to the power minus j. Here it is 3, k is equal to 3, and 5 by 2, and here n is 3. Okay, so these are my coefficients, and I have 1 by n of t is 1 by 4. Okay, so here it is usually 0. Okay, so x1 e to the power, you can see that j5 e to the power minus j5. So e to the power minus j5 will become minus 1. Okay, so it will become minus 1. So x1 is 1, this one is minus 1. Okay, this value. Okay, so you can evaluate it. Okay, in MATLAB, if just type this in the MATLAB command and see, you can see that this will be minus 1. Okay, MATLAB command prompt, you can just type it and see, you will get the value. Okay, minus 1. Okay, and you can evaluate it through the Euler formula also. Usually I am doing that method, but I am not going to do it again and again because it will be very boring. Okay, so here 1 minus 1, and here x2 is 2, x2 is 2, and we have j 2 5, that means 2 to cancel out, you have 2 5. So minus j 2 5 e to the power minus j 2 5, you will have 1. Okay, here you will have 1. Already we see that, no? This is 1. When we are proving the periodicity of this function e to the power j omega naught t, we see that e to the power minus 2 5, if the j 2 5 minus j 2 5 and 4 5 3 5 4 5 6 5, so on, we get 1. Okay, so here also we get 1. Okay, and here x3 is 3, and into the power, you can see that 9 by 2. Okay, so you will get here 1. Okay, so use MATLAB and verify this. Okay, so I don't have any complex value here, no? Minus 1, 2, so I have 2 and 2, so here minus 1. Okay, okay, that means minus 1 minus 4, so minus 2, and I have minus half. Okay, so this is my third coefficients. Okay, see third coefficients, that means C2, 0, first and third. Okay, then I have to evaluate my last coefficients. Okay, k is equal to 3. K is equal to 3. Okay, so that means C3. Okay, I have to evaluate C3. So in the same manner, we have the summation 1 by n naught. So here n is from 0 to 3. Okay, xn, these are very easy. Okay, don't get confused. Just you have to put the value here. Okay, and only multiplication and addition is there, but much multiplication addition is there. Okay, so some techniques we have developed to reduce this multiplication and addition. Okay, we will try to discuss them later on. Okay, so we have xn e to the power minus j. Now k is 3. Okay, omega naught is 5 by 2 and n. Okay, so we have this. So if I have expand this, I will get 1 by n naught. Okay, so here in x is 0, so x 0 e to the power 0 plus x1 e to the power minus j3 5 by 2, n is 1. Okay, plus x2 e to the power minus j3 5 by 2, okay, 5 by 2, omega naught is 5 by 2, and n is 2 here, okay, and x3 e to the power minus j3 is equal to 3 by 5 by 2, 2, okay, sorry, 3, okay. So these coefficients you have. So if you simplify is 1 by n naught is 1 by 4. Okay. So here you have 0 as usual. And x1 is 1. Okay. So e to the power j, I have write it here. It is plus j. Okay. And here we have x2 is plus 2. Okay. So this value is minus 1. You can see it in MATLAB, okay, but I have written it in the paper. That is why I tell it directly, okay. Minus 1, okay, and here it is 3, okay, 3. This value will be minus j, okay. So this value you have to calculate through MATLAB, or you can use Euler formula to calculate, okay. Both way is possible. I prefer if you like Euler formula, then you can get the understand, okay. After getting the understand, you no need to do it. 1 and 2 you can do it manually, okay. After that, after getting the idea, you no need to do that, okay. You can just use a MATLAB or calculator or anything and you can calculate it, okay. But do it 1 or 2 times manually, then you will get the idea clearly, okay. So we have this coefficient. So if I simplify this further, you can see that here 0, 1j, 3j, that means 3 minus 2, no? Yeah, minus 2j, here minus 2 also. So we have minus half minus j half, okay? So this is our C3. Okay, actually we have to find up to C3 because we have to find 0 to n naught 1. Okay, 0 to n naught 1, n naught minus 1. Okay, so n naught is 4. So we have to evaluate all these things from 0 to 3. Okay, 0 to 3. 0 to 3 means we are going to evaluate it up to 4 number. Okay, just I get the idea here. 2, 3. That means 4 value. 1, 2, 3, 4. So we have completed one period. Okay. So we have to do it up to 0 to n naught minus 1. Okay. So any point you can start. Okay. You can find 1 to 3, 1 to 3 up to 4. Okay. You can evaluate it 1 to 4. That is okay. And you can evaluate it minus 1 to 2. That is also okay. 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 Although we have mentioned that k is 0 to n naught minus 1, that is not same. You can change, but the range should be 0 to n naught minus 1. You have to keep this range, but you can shift this value. Okay. So get that clearly. Okay. So okay. So this is C3. Okay, and if you want to calculate the coefficients for k is equal to 4, okay, C4, you can use the same method, okay, and try to evaluate this as a homework. Okay, try to evaluate this value. You will get that this C1, okay, C0 is equal to C4. Okay, you can get this. Okay, you can get this result. Okay, actually for this result, it is a property of discrete Fourier transform. Discrete Fourier transform. Okay, we called it periodicity property. Periodicity property. Property of coefficients actually. Okay, coefficients. So at the beginning we have seen that every discrete time Fourier series Fourier series is convergent. Okay, actually that is convergent because of this property. Okay, so after in node, okay, after the sample here, the node is 4. After in node, the coefficients are repeating. Okay, so we can say that Cn is equal to Cn plus n naught. Okay, this is a property of a Fourier coefficients. Okay, so you can verify it. Okay, so you can verify it. You can leave the meeting, no need to be here. Okay, if you have the lecture, you can leave. Okay, I have uploaded this so that you can you can go through this and you can ask question if have. Okay, now you can wind up and you can go, no need to be here. Okay, you can go. So this is another property actually. Okay, we will study some of properties later in the Fourier series. Okay, but this one is one property. Okay, okay, no problem, you can leave. Okay, no need to be here, that is why I tell you. Okay, ඔකට්ටේ යන්න පුළුවන්. ඔකට්ටේ දැන් 3ට කොහොමද ලෙක්චර් එක දෙනවා. ඒකට යන්න මම මේක කරලා දානවා. හරි. Right. So this is called periodicity property. Okay, so that is one thing. Okay, so you can see that you have already evaluated the all coefficients. Okay, all coefficients. Okay, so this C naught is evaluated, C1 is evaluated, C2 is evaluated, C3 is evaluated, C naught is what is the value? I have write it somewhere. C naught is 3/2. No, C naught we have 3/2. Okay, and C1 we have, it is a complex value. We have half plus j half. Okay, so this is a coefficient. This coefficient is a complex coefficient. Okay, and C2 we have C2 we have again real coefficients. It is minus half. No, we have minus half here, and C3 we have, it is again complex coefficients, minus half minus j minus half, this one. Okay, so we have found this C0, C1 and C2, C3. So this is our Fourier series representation of this signal. Okay, for this signal. Okay. So I hope you get it. Okay, I hope you get it. Anyway, I will do it again and upload. Okay, so you can prepare it. Okay, so so let me discuss another example. Okay, let me discuss another example. That is this one. So here we have some Fourier, some signal, discrete signal. So I will get a general one. Okay, xn is equal to, so we have to evaluate xn is equal to cos omega naught n. Okay, so we are asked to find the Fourier series of this signal. Okay, of this signal. So you can see that omega naught is equal to, sorry, our n naught is equal to 2 pi by omega naught. Okay, so you have to prove this. I have I have given this as a homework, so you can find it. Okay, so if you can't, in next tutorial I will do it. Okay, so try to do it yourself. Okay, okay, so here we have xn cos omega n omega naught n, and n naught is 2 pi by omega naught. Okay, so I think you can remember when we are dealing with the continuous time signal. Okay, when we have this kind of cosine wave to express the Fourier series, we always go through Euler formula, no? Because if we have to do the integration, it is somewhat hard. Here also we have to do some summation, okay? And it is hard to identify the summation point actually, okay? So if you're going to evaluate the Fourier series representation of this signal through our principal method, it is somewhat hard. It is not impossible. We can do it, okay? But sometimes you can see that in continuous time signal, sometimes some integration not exist, okay? So these are impossible. But here in discrete time, that is not happening, okay? Because we can't say that summation is not exist. Always summation, we can get the value for the summation, but we can't always get the value for integration, okay? Sometimes integrations are not exist, some integration, okay? So we can evaluate this through principal approach. Definitely we should be able to do this, but we will use the Euler formula, okay? Because if you have this kind of question in exam within cos or sine term, you can directly use Euler formula and do this as you have done in continuous time case, okay? So we will do this. Okay, so I am going to use the Euler formula simply, okay? So one important thing is here, I hope we can figure out, okay? So you can leave still ආදී ඔකටට යන්න පුළුවන් හරි මම මේක කරලා දානවා. Okay, so we have, if you use the Euler formula, you know the Euler formula, j theta is equal to cos theta plus j sin theta, okay? And if you write t minus j theta, you have cos theta minus j sin theta. So if you add this thing, you have 2 cos theta is equal to e j theta plus e minus j theta. So cos theta is equal to e j theta plus e minus j theta by 2, okay? So you can use this method, okay? So I directly use that, okay? So here xn I can express as e to the power j omega naught n by 2 plus e to the power minus j omega naught n by 2, okay? So this way I can write, okay? So now we have to find the coefficients, okay? We have to find the coefficients. So if I write the Fourier series representation for any signal xn, okay? So I have this kind of one, no? I will put here k0, okay? Here actually k not should not be 0 to n naught minus 1, okay? It can be changed. It can be minus 1 to n naught, 1 to n naught, minus 1 to n naught by 2, minus 2 to n naught by 3. Likewise, it can be happen, okay? So here I will consider from 0 to n naught by 2, okay? So I have, so anyway, I have considered this minus 2 to some value, okay? N naught by 3 it should be n naught by 3, no? If I consider minus 2, it should be n naught by 3, okay? Because 0, n naught minus 1. If I put here n2, again 2 sample will shift to here, no? That means n naught by 2 minus 2. So I will have n naught minus 3, okay? So up to n naught minus 3, n naught minus 3, okay? We have ck e to the power jk omega naught 10, this kind of series, no? So if I expand this series, okay, I will expand this series. So I will have xn is equal to, so I get from minus 1, okay? So I have c minus 2 e to the power j, k is minus 2, okay? K is minus 2 omega naught n, okay, plus c minus 1 e to the power j Now k is -1, so k is -1, omega naught n plus C0. Now k is 0, so e to the power j0 omega naught n, that means e to the power 0, that means 1. So I have only that coefficient C0 plus C1. Now k is equal to 1, so k is equal to 1 omega naught n a2 e to the power j2 omega naught n, so on it is go up to a n minus 3 e to the power j n minus 3 omega naught 10 up to this level. So I have these coefficients. Okay. So now compare this one and this one. So you can see that you can see that here you have the same identity, no? So you have some coefficients here, okay, and you have some e to the power terms. Okay, so here also we have e to the power terms. Okay, so you can compare this and this. So you can see that already we have we have represent this cos omega naught n as a collection of exponential harmonics, no? Weighted collection of exponential harmonics. We have already done this by using the Euler formula and change it to the exponential terms. We already convert our we already represent our signal as a collection of harmonics. That means Fourier series representation. We have done. Okay, so what we have to do is we can just compare the coefficients and this value, the k value. Okay, so you can see that okay, here the k should be 1. Okay, because j omega naught 10 k should be 1. Okay, this one. Okay, so we have c1, no? So this is c1, coefficient c1 is equal to half. Okay, and here you can see that it is minus. That means this k is equal to -1. That means it is c minus 1, this term. Okay, only this term and this term available. These are not available for our signal. Okay, so this term and this term available. So you have c1 and c minus 1. So c minus 1 is also half. So the important thing you can figure out is that we get k is equal to 0 to n naught by 2 in our principal approach. Okay, but you can see that k here from -1 to 1. Okay, so that also okay. Okay, so you have to keep this range, you have to maintain this range. Okay, but you can shift the value. Okay, please note that. Okay, so I hope we have complete the Fourier series. If we have time, we will see some properties. Okay, and I hope this is enough. Okay, so we will wind up here. Okay, okay, thank you for being here. Okay, okay, I will stop share.